One of the questions that we have is what does the inverse of this thing look like? And what does the inverse of this thing look like? Does anybody immediately see the inverse of this one? Do you remember what the inverse of a shear matrix was? It was on that board. Take the 2, or the negative, and turn it positive. So anything that's not on the diagonal, just switch the sign. Could you make a prayer? What's the prayer? Yeah. Guess what? It's exactly what it is. L inverse. Note. Could you prove that to yourself? If this is I3 minus T1 E1 transpose, and I take the inverse of that, can you guess what we're going to say the inverse is? The inverse for a Gauss transform LK inverse. So let me ask you, could you guess what the kth Gauss inverse, Gauss transform does? What did the first Gauss transform do? What did the first one do in this case? The first Gauss transform zeroed out all of the first column entries under the first pivot. The second Gauss transform zeroed out the second ones. What's the third one? And the fourth one? And the kth one? So the kth Gauss transform starts with the pivot k, which is the kth element of your matrix A, which already been transformed, and then all subdiagonal elements of that thing, it just picks them off one by one, right? What's the inverse of a Gauss transform? What are we learning about that thing? We said that every Gauss transform, we could write it as an identity, rank 1 update of the identity, where we have a Gauss vector in the kth column. What was the lesson we learned about shear matrices? If this was a plus and I took the inverse, we turned it to a minus. If it's a minus and we take the inverse, we turn it to a plus. Wouldn't that be a great test question? Those of you that have had me before probably just realized something. And those of you that haven't, maybe you want to pay the person that just realized something. Right, so that's a conjecture that if you want to take the inverse of one of these things, it ends up looking like this, right? And what that means immediately is L1 inverse times L2 inverse. Okay. So let's take a look at this. This was, what was L1 again? L1 was 1, 1, 1, negative, negative, 0. If I take the inverse of that, what happens? It becomes positive. And then what? L2 inverse. L2 was 1, 1, 1. This was a negative. That became positive. Okay, and this is where things just get gorgeous. Do you remember what we said when these were reversed, we couldn't just fill this one in? Do you know what happens when they're in this order? Try it. What do you notice here? So let's do the column version here. This is where it's really, really nice. What do you notice about this thing right there? So if I take this matrix by this column, what does it do? Picks off column 1. Isn't it nice to have all those options on which one you're going to do? Okay, what about this one? 1 of column 2 and then what about this one? You all don't know how cool it is that you're answering that question with full understanding. I mean, it seems like it's just standard to you. It's a huge deal that you all can just see that. That's taking a lot of work to get there, and I'm so proud of you. Which is pretty freaking amazing. Because what it means is, actually, if you... So one thing, what do you notice about this thing? What structure does it have? It's a unit lower triangular matrix. Could you guess what we call that thing? Which means we actually could determine the entire structure of L in these steps. I don't even have to do, so here's the claim. The moment I know this, do you know what I know immediately about L? Just take the negative and store it. The moment I know this, do you know what I know immediately about L? Take the negative and store it in the next column, right? And then I can just work my way down, and eventually I'm going to get to a point where I've formed all of L